Welcome back to my channel Shri Statistics. So today we are going to talk about some properties related to the trace of the matrix. So suppose there is some matrix A denoted by Aij, which has m rows and n columns, or as it can be seen as it's written over here, A11 up till am1, that is m rows, and up till n columns. And similarly we have B of the same order, Bijmn, that it also has m rows and n columns. So suppose that A, B and BA coexist, then the trace of AB is equal to the trace of BA. So the proof can be seen over here that the ijth element of AB will be, supposing we have to take a summation of it. So it will vary from, k varies from 1 to m. That is from this row till this row. This is the summation we are taking. So this is the ith row. When this k remains constant, that is we consider this ith row and this jth column. So the ith element, that is the diagonal element, will be, in place of j over here we will substitute I, and otherwise this kth element will remain the same. So summation of these equals to the trace. If you would recall from my previous video, that this is what the definition of the trace is, the sum of diagonal elements. Similarly, for the ijth element of BA, then again we consider the element which is on the ith row and kth column, and then kth row and jth column. So this portion, this is again from the definition. So then the ith element of this again will be substituting I in place of j. So again these are the diagonal elements which will give us the trace, this trace BA. Thus trace BA is equal to the summation from k over k, that is from 1 to m, and that this is bki aik, and then this is again the same value aik bki. That was over here, over here, aik bki. So it can be seen that both of these are equal. These two values from this derivation, it can be seen that both of these values are equal. So this is how it can be proved that these two traces are equal. So for the rest of the properties, keep watching my channel. Thank you for watching.